Hi, I'm Corbett. Sometimes I am an idiot. I am not an engineer, but I do think through the home performance aspects of things and the building science, the invisible dynamics. And that's all this channel is about. And the work that I do for my clients is about that too. This is a plan that I just wanted to make sure everybody is clear. The code officials, the people who are doing the building inspections or the permitting, are gatekeepers. And sometimes they can take a plan like this, which is not pretty. Like, I'll be the first to admit. But it works. It will work. It is all based on calculations, and it is based on thorough thinking through of the effects of heat bleed, airflow and pressure, moisture, and contaminants, using all of the things that I know about indoor chemistry and microbiology and things like that to help control these dynamics. And they can just say, this is not going to work. And then you can say, well, where in the code book does it say that I can't do this? And they can still say, well, it's my opinion, this is not going to work unless we have a stamped engineer print. And even though this is not pretty, I want to show you why you want to do a QC on a stamped engineer. Just because something is stamped by a professional engineer, which I am not one of. I used to be a musician before I did this. I've been doing this for 16 years. And so anyway, part of my job is to work with amazing people who are trying to build their own homes, and they want to make sure that they're doing things right. This is a plan that is very beautiful, and that might lull you. So what you've got here is a whole bunch of symbols that are going to seem like very fancy and, oh, like I shouldn't ask any questions at this point. So this was a plan that we went over a couple of weeks ago. You can see that they've got scheduling here. What we have in this house is the hydronic air handling units. These are all high wall, basically ductless mini splits. So we've got these high wall indoor units, no particular duct system. We have an air to air fixed plate energy recovery ventilator schedule. That's the ERV. We've got two Zehnders, and we're going to be talking a lot more about the Zehnder system in this video. And for that, I brought an expert to talk with us. Everybody meet my friend Zabi.
Hey everyone, my name is Sabi Fekete. I'm working for Zehnder. I am one of the coding engineer and designer and tech support at the company.
So I'm going to be cutting away to Zabi's take on some of the things that I'm talking about, and just to get like the extra granular details that I think are really important on this design. Here we go. The first thing that I'd like to point out is that even though this is a stamped engineer's plan, and this person is a professional mechanical engineer, which makes them technically a level above the work that I do, there is no filtration strategy built in for this home. There is no humidification or dehumidification conveyance built in, meaning because there's no duct system, we have no way to get dried or humid air around the house. And makeup air for the kitchen exhaust is not specified or detailed in this plan. And all those, I think, are super important. That's why I came up with the 5 factors: circulation, capture and filtration, humidity control, dilution air, and pressure relief. You got to at least think about all 5 of these factors.
Your comments are excellent. So the 5 points, what you're mentioning, and all of these details, what you talk about, the filtration, the balancing, the makeup air, the location of the registers, this is excellent discussion. Anytime when I'm teaching, I always bring these up to everybody that please be careful what you do and how you do. Extremely important topic, what you mentioned, dehumidification and humidification. Any home, new build construction is releasing a tons of moisture because of the material what we used. We're getting lots of phone calls from customers, unhappy customers telling to us that our units are screwing up their home and they have constant 68 to 73% humidity inside of the home during summertime. And I try to explain to them that, first of all, ERV or none of any ventilation equipment is a dehumidifier. Identifying ERVs or HRVs as dehumidifier, it's a wrong statement. We're only moving air. As soon as outside air is more humid than the inside air, we're moving humidity in. We want it or not, it happens because of physics. And in the winter time is the opposite. We're drying the homes out slowly. So unfortunately, in extremely high performance homes with extreme air tightness, the homes in dry winters start drying out. And yes, you can get down to 22, 25% humidity when your cabinets, your furniture, your floor start to moving because of the humidity dropping significantly.
So we can see that we do have an ACA manual J rooms load. So that tells us that even though this person is a professional engineer, and I would warn all of you that if you are working with a professional engineer, they probably mostly work in commercial buildings, which does not fall under manual J. Manual J is only for residential. So the fact that they put manual J in here is good. We can see some interesting, like what looks like wiring diagrams here. And like, this is where you start to, if you're like me, feel a little intimidated. Like, gosh, I don't know what I'm looking at. But what we see here is that we've got the ERV over here, the outside air coming in, and then the exhaust going out and going into the ERV, and then somehow kind of going around these air handlers, which again, we already discussed are ductless units. So I'm sure that this will be detailed more as we go, but we've got like what looks like a damper here, a manual damper. We don't have to worry about this right now. I'm going to show you more, but I'm just like, I want you to feel what I feel when I look at this and what my clients certainly feel, which is like being a little bit out of my element. And what I'd like to share with you is the way that you solve this riddle is you read the fine print. You just look at it for long enough and you read every single little thing and you start to notice that like, oh, we've got a temperature room sensor here. We have this valve here. We've got this, whatever this is, and I can go back up to my key, the legend for all of the symbols and be like, okay, what are these things? So if you start reading through this, you will start to notice some things. There are a couple basics that, since we're going to start diving into this Zehnder system in a minute here and kind of pointing out some of the mistakes that are very important for you to notice about a plan like this, is that the outside air coming in, you're going to have two of these for two ERVs. You're going to have 2 points where you're going to bring outside air in. In general, I want those things, if it's my home, to be in a place where I visit often, like near my front door, over my front porch, somewhere where I'm going to be like passing by and I can look up and see if there's a wasp nest growing in it or if there's a dead animal laying underneath it. Those are important things to know. There's also going to be an intake for the makeup air, which again is not detailed in this plan. So you're going to have potentially in a house that has 2 ERVs plus a makeup air, you're going to have 3 ducts that are need to come inside. Let's group those all at the same place. So we know if we keep this place, our front porch, really clean and free of dead animals, we'll be good. The air inside our house will smell good. Likewise, the exhausts that are going here to outside, the ERV exhausts, there are 2, plus we're going to have one from the kitchen exhaust. Those things should ideally be grouped together so that we know we have a stinky side of the house and we're not having anything like backwash between the exhaust side getting sucked back into the house, because that's just not ideal for a high performance home. We can see here we've got even more of these wiring diagrams, and this all, whether it's intended to or not, has the effect of making somebody who's looking at it feel like, whoa, I'm not going to ask any questions because I feel like they're probably going to be dumb questions. So here is where we start really looking at what is going on. We've got our ERVs located in the mechanical room in the basement. So we've got our air handlers here. We've got 3 of them. We've got 1 over here in the primary bedroom. So here's the basement level, and you can see that there are these kind of, what in Zehnder world, what we do is we deliver to these manifolds with these big ducts. They're generally 8-inch ducts. And then we're gonna, from the manifold, we're gonna take these Comfo tubes, which are these flexible 3-inch pool hoses basically, and route those around, and it becomes very easy to get around things because they're flexible. So for ease of install, yes, that's nice. There are some downsides here, and so that's what we're going to start looking at here. This is the basement level, and then here we've got first floor, and you can see there are a bunch of things marked out. This is only the ERV being detailed on this floor plan right here, and then the top floor is here. Here is what I started to notice when we start actually looking at this. The top floor, what we see is we have a bathroom here, bathroom number 2. This is a shower. There are no exhausts detailed in this shower. There are 2 detailed in the toilet room, which is separate from the bathroom at large. Each of these Comfo tubes, these 3-inch hoses, deliver about 12 CFM. So you'll see Zehnder, if you get a quote from them, they'll say this room should get 25 CFM, therefore 2 Comfo tubes. This room, 12 CFM. Like a toilet room, they'll often say 12 CFM. A laundry room, like a little weird closet that you've got in the middle of the house that's not going to get circulation otherwise because it has no load, 12 CFM. So 1 tube, 12 CFM, 2 tubes, 25 CFM, and so on and so forth.
The 12 CFM is an average CFM rate for the 3-inch pipe on medium speed. We normally design our system between 45 to 65% capacity on medium speed. When you trigger the system for a higher mode, higher speed, the unit ramps up and start utilizing that extra 45% capacity. So your 12 CFM per tube actually is jumping up to 18 to 22 CFM.
Both tubes being in this toilet room becomes a problem because we're not grabbing the humidity, which is the main job of bath exhaust, just to remind everyone. This right here is an A. You can see this is an X, that's exhaust. An A is a supply, the way that this thing is set up. And I don't think it's a good idea to pressurize a bathroom. Remember, there is no other air conveyance in this home. There's no other ductwork. So right now what we're doing is potentially pressurizing this bathroom and then depressurizing the toilet room. And so air will be flowing from the bathroom into the toilet room, but who knows what's going to be happening with this shower here. So we need to move at least one of these things in the shower, but that's only 12 CFM. Code actually says we need 20 CFM in a room that has a toilet or a shower in it. So each of these rooms should get 20 CFM. I like to say 25 in the shower because it's more important and 15 in the toilet because it's less important. But in any case, we got to shift this around. I would get completely rid of this supply in the bathroom and just have exhausts. And if they want to have 2 exhausts in the toilet, that's fine. Add 2 more in the shower. Over here, we can see another bathroom with a shower, with no exhausts over it. And it's not even like we need to have this thing be wet rated and have a GFCI on the thing. Like, these are literally just ports in the ceiling. There's no electronics in this thing. So you just put the ports, the holes, with the tubes connected to them wherever you want.
Shower details. The shower room's normally not enclosed on the top. Even if you're not putting extract register into the shower, just put it outside to the shower, it's fine, because the humid air, when it's reached the top, the ceiling, it will float out. It's important we're putting these extract points to the top of the room, high walls or ceilings, because that's where it starts to filling up. Warm air sits on the top of the room. It's just physics. 2 registers in that bathroom could work, but I would not put them into the toilet room, that's for sure. I would use 1 register to the shower, to the toilet room, lower CFM rate, and then other register somewhere in the bathroom, close to the shower, or even you can put it to the shower as well. It's nothing hurt the system if you put it to the shower with 2 tubes. So you can pull 24 CFM from the shower room or the main body of the bathroom, and the additional 12 CFM from the toilet room, and you get total of 36 CFM out from that room on continuous ventilation without the boost mode. Code requirements, if we're reading the latest codes, says that bathrooms and toilet rooms requires 20 CFM. So during our design, when I design, and we have just a powder room, for example, powder room supposed to have 20 CFM in, even there is no shower there, because code requires 20 CFM continuous ventilation in the powder room. If you have a combined bathroom with the toilet room, it counts as 1 room, so it's technically 20 CFM. But as we discussed and as you mentioned, it's perfect and it's great if you have 1 separated register for the toilet room. It could be 10 CFM, 12 CFM, 15 CFM. You can go up to 15 CFM with single tube if it's a short run. That's our max, where we're maxing out, just to keep the noise away from the system, obviously, because again, we are low velocity. And to the bathroom, you can go with the 2 pipe of 20, 24, 25 CFM, and you can get the code requirement for the toilet room and the bathroom with the 40.
I just want to remind everybody, if you do have a Zehnder system, you have these little filters that are actually built into each and every one of these little extract points. So you need to pull the grill off and you need to take that out of there and clean it once every couple months. We also have an exhaust in this closet right here for some reason. By the way, don't put supplies in closets for sure, because you don't want to have air that's less than full temperature and ideal humidity in closets that are full of soft stuff, because it'll those soft things, the clothes, end up being insulation on the temperature side and also a sponge for the humidity.
Corbett, you mentioned that don't put supply into the closets, and I agree with you on most of the cases. However, in some cases, especially we see that lately with the new constructions, when they have the master bathroom between the master closet and the master bedroom. So in some cases, we're putting supply to the master closet to be sure that the air is actually pushed towards the master bathroom. We normally do not want the fresh air getting into the closets. However, if I have to make a choice, but I don't want fresh filtered air in my closet, even with a little bit higher humidity, or stinky bathroom, high humidity air into my closet, I pick the fresh filtered air.
In the loft/library, we have this supply, and then we have this exhaust over the window seat for some reason. In general, this is a really good example of explaining the way that I like to think about things. If you look at a hospital, the way that mechanical engineers design hospitals is every room generally is going to be either pressurized or depressurized. So it's going to be a positive pressure area or a negative pressure area. Rooms where you have to be doing really delicate stuff like an OR, you don't want any sick people stuff coming into your room, you're going to pressurize that room with air from outside. We purify it, we condition it, we do everything we want to it, make sure it's perfect. We put it in that room, and then air only leaves that room and never comes in from any room around it. In a room where you're going to put somebody who's got a terrible disease, you're going to put them in a depressurized room so that air from around that room falls into the room and no air ever leaves the room. In general, we want to use the same kind of principle in a home so that we know where the air is going to flow. Bathrooms depressurized, bedrooms pressurized.
So normally, as you mentioned, we're having suction points in the bathrooms, kitchens, storage rooms, where the air could be contaminated. It could be stink, chemicals, or humidity. And we're dumping the fresh filtered air to the other sections of the house, keeping those rooms positively pressurized. We're talking about bedrooms, living rooms, dining rooms, the normal common areas. And the air naturally, because of the pressure difference, will start to travel. And we actually have transition zones as well, so we don't have to put supply registers to each room. The rooms between point A and point B will get the fresh air traveling through and get to your suction point. Convection is always exist in the house, and convection moves the air. I'm from Europe, and in Europe we have radiators in a bunch of homes. There is not even forced air system, and Europeans building the homes with concrete and blocks, so they are pretty airtight homes, and the air is still moving through the rooms because of the convection inside of the house.
First floor. You can see again, we've got this entire bathroom up here with a shower. This is a very, very wet room. We got a standalone tub and we got a big shower. No exhaust anywhere in here. This, B, is another supply. So we were actually, again, pressurizing this bathroom. We're depressurizing this toilet room with, again, 2 of these exhausts in the toilet room for some reason. We have an exhaust in this walk-in closet. That's not necessarily a bad thing, although this, in this case, because we don't have ductwork, this is something that would be useful, because otherwise this room, none of these rooms is going to get any airflow, because again, the air handler is way out here in the bedroom space. So this is a way to get the air handler's air to go into the closet. But then from there, what you're doing with the ERV, just to be clear, is throwing it in the garbage. In ERV, especially a Zehnder, doesn't even have the ability to recirculate the air. And in general, if it does have that ability, you're going to disable that ability because you don't want that if you're using a toilet exhaust. Here is an example of something really crazy. This is a powder room. And what we've got here, this Y is an exhaust. And right next to it is a supply. Right next to it. Both of these things, especially in a Zehnder kind of situation, are pretty low velocity. So 12 CFM is coming out here, and it's going to turn right around and get sucked right back out there. I'm not sure what this is doing, but we're making the room pressure neutral, so it's possible that odors might escape and hang out and then escape into the hallway because there's no real incentive for air to move this way under the door. So generally, don't put supplies and exhausts together. Here's another one, a supply and exhaust right next to each other in the laundry room. Here is 2 supplies in the kitchen, and here's another supply in the kitchen. Generally, kitchen would be another one of those places where I would, if anything, want to depressurize a little bit rather than pressurize, because we don't want air from this kitchen drifting over into the dining room. If someone forgets to turn on the exhaust hood in this kitchen, because it's pressurized by these three 12 CFM apiece, that's not very much, it's going to go other places if they are not using the kitchen exhaust hood again. Okay, and then just to wrap it up, on the bottom floor, there are no supplies or exhausts in the entire basement, mechanical room, or either of these crawl spaces. And I think that that is kind of a mistake. So we'll just leave that there. There may be a reason for that basement thing, but I wanted to clarify a couple other things. Currently, when we talk about the floor 2 system here, when you do the count, we have 7 extracts and 7 supplies, another 84 CFM. So we've got balanced floor 2, 7 extracts, 7 supplies. On floor 1, we have 6 extracts for 72 CFM and 15 supplies for 180 CFM. That's a pretty big imbalance. And in fact, when you add these all up, what we have is 156 CFM of extract and 264 CFM of supply. That's not balanced. And what you might think is, oh, well, maybe we're trying to pressurize the home. I think in general, it's not like an imbalance like that. 156 versus 264 is about 100 CFM of unbalance. And I'll tell you that that's not going to pressurize the house as much as you would think. As soon as the wind starts blowing, it can kind of overpower that. Also, that unbalance turns your ERV from a recovery device that's balanced into something that doesn't actually act like an ERV anymore. An energy recovery core is based on an equal amount of air leaving the house and coming in, and they brush against each other. Once you start unbalancing that, and it's like this, it's not going to recover nearly as well as you can imagine.
By the way, I'm not surprised that if it's not balanced, because you have no idea how many times I'm calling the MEPs and saying that, guys, you have to relearn math, because adding together 6 numbers on one side and 6 numbers on the other side and be sure they are matching, it's not rocket science, but it's sometimes challenging. Let me make a note here. Are you sure that those numbers above the register notes, the 20s, 30s, those are not the CFM rates? Are you sure that these are 12 CFMs?
So Sabi is exactly right. And this is why you want to have friends. I missed when I'm looking through the fine print here that there's a number here. This 30 is pertaining to the amount of CFM that we want to pull out of these. So now, recalculating what I just said, which is not correct, we now have on floor 2, 210 CFM of exhaust and supply.
I can't believe that that second floor is more than 2,500 square feet. That's, yeah. Let's be extreme. 3,000 square feet with 9-foot ceilings. That's 27,000 cubic feet of air. So we have 210 times 60, 0.4666 ACH rate. So that's way more than we need.
That is basically exchanging all the air on the entire top floor once every 2 hours.
Correct.
And on floor 1, we have 150 CFM of exhaust and 460 CFM of supply. Does the biggest machine you guys have, the Q600, does it even do 460?
No. So our biggest machine, the Q600, full capacity is 353 cubic feet per minute on full capacity with perfect installation and excellent design. I have a feeling that this mechanical engineer designed the extra airflow to compensate for some kind of ventilation in the kitchen, range hood. And they tried to use our ERV as a makeup air. That's a very common question, you believe or not. It's so many times I'm getting this question that can we compensate for makeup air with our ERVs? We cannot to compensate for makeup air. There are multiple reasons. One reason is because of the performance, the full capacity of the unit. So think about it. Our full capacity is 353 CFM on our unit. If you have a 600 CFM kitchen range hood, we can't even reach 600 because the max what we can put is 353. Second, I jump back again to one of my favorite topic, physics. During winter time, just think about it. What's going to happen with the core when you don't pump warm air out, only pull cold air in to just compensate to your kitchen range hood, the core will freeze up in no time, and the ice forming on the core will reduce the airflow. And what's going to happen is you damage the core, you screw up your home because you're dumping straight outside air into the home, and technically there will be no energy recovery at all, and you will have to have a service because the core is damaged. If I'm pumping out 100 CFM, I want to bring in 100 CFM because that's when my core has the best recovery process. And also, Zehnder has a built-in algorithm which doesn't even allow more than 15% unbalancing.
That being said, this house is going to be tight enough that if they put even one vented dryer in this house, this is aimed for passive house air tightness, so 0.6 ACH50, a 150 CFM dryer, vented dryer in this home will depressurize the whole home to 6 pascals. So that again is why this makeup air that's missing in this plan is so important for this kitchen exhaust, whatever it is. And the fact that this is an island means that that fan has to be even more powerful because we're not using geometry to help with the flow.
Keep in mind, adding more parts and more registers increase the cost. Ventilation is extremely important, and important the proper way, but over ventilating the home, it's not helping no one. And also over designing the system with lots of connections and piping and manifolds and registers will significantly increase the cost, and it will increase the labor fee as well. It's actually very interesting that United States is exhaust-based code, Europe is supply-based. In United States, we have to base the ventilation on number of bathrooms and kitchens because that's when we're sucking the air out from. In Europe, they calculate how many bedrooms you have, how many square foot of living space, and how much supply air you need, and they can match up the bathrooms with those supply rates. So you keep the house balanced. You can do extract points in individual rooms because, again, the American market is extract based. But on the supply side, you can just dump it to the air handler, to the return plenum, and it will distribute it through the ductwork. So I just said that if Corbett said it's okay, I don't see any problem with it. It's not the ideal design what we like at Zehnder, but it's very commonly used in lots of homes because of the cost.
Awesome. Thank you very much, man. I really appreciate your time.
Thank you, Corbett. Have a great weekend.
So all that, I just wanted to make sure is clear to people. Like, I'm not an engineer. I used to be a musician. I can look at this for just long enough. You could use the same technique in an art museum. You don't understand a piece of art, just sit there and don't think anything and just look. And then you'll start to be like, oh, that's interesting, and I'm noticing things. When you start to really look at these things, it would be kind of amazing to look at other engineering layouts, and we'll continue to do that on this channel, and find all of the things that like you would be a little bit worried about if they were actually spelled out in plain English. So please do this when you get a set of plans back on a home that you're building, or a renovation, or an addition that you're building. Look through it and really start to just think about it. Like, clearly, the mechanical engineers are not rocket scientists. They get rushed. They might not think about these things. Somebody has to, and if you're watching this channel, you probably care more than other people. So please do comment below if you have other things to add about a Zehnder system in general, or about working with mechanical engineers as well, and things that you might want to recommend for people as they move into this kind of a process. Like and subscribe. Tune in next time.